want to welcome our guests, first of all, to Future Studio, first project, and the results of the first project, which we'll see in a few minutes. We're still waiting for Marcus Berger, who should arrive soon. He's a professor here, he teaches in interior architecture, he's going to be a critic. And Martina Decker's here from our firm in New York. Martina's been teaching at Parsons, product designer and architect as well. But this is the first project. It was a 4-week project, and the studio is focusing on some materials with novel properties generally in the middle of the semester. So we're going to be starting today looking at some nanomaterials like carbon nanotubes, for example, but also some smart materials. We're going up to Brown to meet with some people at the Institute for Molecular and Nanoscale Innovation there today. After that, the last project of the semester is looking at nanorobotic devices. These are molecular machines. But as an introduction or a preface to all of that, we're actually looking at some not terribly smart materials and just at their material properties through this construction that we've assembled, which is really a chain reaction between various objects and fluids. And the objective, there were a few objectives to this assignment. One was to, first of all, observe different forms of energy. So some of these devices operate because of gravity, some because of an electro or magnetic field, some because of heat, some because of light. We have a motion sensor up here that works because of light, for example. So you'll see different forms of energy that are imparted from one segment to the other. And you'll see materials respond to that energy in different ways. Things expand, things relax, things contract, things get impacted. And so there are direct analogies between these objects and the materials and really smart materials that we're going to be looking at in the second segment, where those materials change their properties in response to different forms of energy. They might bend, or they might change color, they might emit light, for example, they might generate electricity because of pressure or light or some other form of energy that's imparted upon them. But one of the challenges in this was to take an object and just to kind of forget what it was used for. So to strip of it of its previous use and just to think about it as a kind of thing discovered again, almost an unknowable, unnameable thing. And to think about it as having some, not only properties, but some potential to do something. And so the students had to really come up with kind of system whereby each person was responsible for a system. They could create some sort of reaction within their segment of the entire system. They could decide what to impart onto their neighbor down the line, but they couldn't make a decision on what they were to receive in terms of materials or a form of energy. So we set it up as a kind of game. One of the challenges was, since a lot of students were dealing with gravity, how do you, if you're dropping things, how do you bring a motion back up again? We found that out. But we ran through this on Thursday. Through starts and stops, and many of the parts were successful. And we're hoping today that we'll be able to run through it without any complications. But I'll ask now, just briefly, each student to talk about their small section of the sequence, just within a minute, so that you know what's going to happen, so you have a sense as to what to look for, all right? So, and then this whole thing runs through in about 8 minutes, I think, if it works properly. So, let's start with Rachel.
When I talk, can you shoot for me?
Starts at that end, ends at this end.